Hey, everybody. I'm Lee Green. I'm the senior medical entomologist with the Indiana Department of Health. And I was asked to talk to you about what's going on currently in the world with vector borne disease and vectors. Um, and because I'm with the Indiana Department of Health, and that's where this uh, in person conference was taking place, we'll kind of specifically dive into our surveillance program in Indiana and what we are currently finding. So, first, vector borne disease has been in the news a lot lately. It's a subject that's really gaining a lot of traction, and several things have gone on in the past few years that have made it a really exciting and interesting field of study. Most all I did was just went on the internet and I Googled vector-borne disease, clicked news, and these are the results that popped up. So first, there's a ton of news articles that talk about the spread of mosquito and tick-borne diseases um, throughout the country and the world. Um, so not only are those mosquitoes and ticks spreading, but so are the diseases they transmit, which obviously would go hand in hand. And there's a lot of implications to why that is happening. Not only our behavior and our movement, and our urban sprawl, but also things like climate change. There's a lot of models working on climate change and the potential diseases that could arise here in the United States and where they could have spread based on climate change models. And finally, something we'll hit on a little bit more later in this talk, but some pathogens and diseases that were a thing of the past are now coming back. And malaria was a big one this year in 2023. So to start off, let's just go with some definitions. And what exactly is a vector? Well, a vector is a bug that can transmit pathogens to us. And that could either be from human to human, or it could be from animals to human. And those are both very big um, groups when we talk about emerging diseases in the United States. So those vectors that are most common here in the United States, the top two would be mosquitoes and ticks. We're all familiar with mosquito and ticks transmitted diseases, but there are also diseases that can be transmitted by flies, transmitted by fleas like the plague, and even lice, diseases like typhus. And there are a ton of vector-borne diseases that are currently being reported to the CDC that are transmitted here in the US. The two biggest ones are mosquito borne diseases, and the second biggest, and what I think is the most evolving, would be the tick-borne diseases. Believe it or not, we still have plague in the United States. We have plague cases every year in the western part of the United States, but mosquito and tick-borne are by far the most common in the Midwest. In fact, these highlighted ones are the diseases that have been reported here in Indiana in the last 5 years. California serogroup viruses, such as La Crosse encephalitis. The deadly Eastern equine encephalitis virus exists in the northern part of the state, and we occasionally have outbreaks on that. West Nile virus, everyone's familiar with, and a whole host of tick-borne diseases. So not only are there a lot of tick-borne diseases and mosquito-borne diseases in the U.S., but we get new ones, it seems like, all the time now. In the last 20 years, this set of pathogens have been first reported in the United States. Chikungunya and dengue, which are mosquito-borne, but a whole host of tick-borne diseases. Some spotted fever group rickettsias, like Rickettsia parkeri and Rickettsia species 364D, which occurs in the western part of the United States, but other bacterium that are transmitted by ticks, Ehrlichia murisochlorensis, which was obviously discovered in the Eau Claire, Wisconsin area, Borrelia miyamotoi, Borrelia mayemii, and as well as some viruses, bourbon virus and heartland virus. And they may seem far away, but especially the tick-borne diseases, we have discovered most of them here in the state of Indiana. So we do have those diseases here. Another thing that gets reported in the news often is the huge increase in vector-borne diseases across the United States. Um, it's often reported that vector-borne diseases have tripled in the United States. So that could be transmitted by mosquito, tick, or flea. But we'll dive into what's really responsible for driving this increase in cases. Because this is the same in Indiana. We have had a huge increase in vector-borne diseases over the last 15, 20 years. The real driver of that is honestly tick-borne diseases. And the most common tick-borne diseases or disease in the United States and in Indiana is Lyme disease. It's one of the 10 most commonly reported pathogens in the whole United States. And as you can see from this graph, Lyme disease in the US is really on the rise, and we'll get to that a little bit later. But before we get into those tick-borne diseases, let's talk about mosquito-borne diseases, because they haven't been increasing over time like tick-borne diseases have. But as you can see from this graph of West Nile virus human cases, we have these large epidemic outbreak years. And we'll talk about what happened this year in 2023. You can't have a vector-borne disease talk without really talking about West Nile virus. And it's a great year to talk about it. This will be the 25th year that West Nile virus has come to the United States. And it's a great cautionary tale, because you can see from this map in 1999, all those cases in the United States were there on the East Coast, and we had very few. I think that we had like 60 some cases in 1999, and that was a really big deal. But because of some of the dispersal characteristics of this disease, it exploded across the U.S. And it's something we have been dealing with now for 25 years in the United States, and it's not going away. So one part of vector-borne disease that this can be is a tale that there's several other diseases across the world where we have this potential for this to occur again. So what happened this year with West Nile virus? We had an average year. Every year we have around 2,000 cases. During COVID, we had a lot fewer, around 1,000 cases. But this year we had 2,300 cases so far reported. And as you can see, the vast majority of those cases occur in the central part of the United States. That's been something that's been going on for several years. And one of the reasons is because of the weather patterns. West Nile virus, those epidemic years are usually drought years. Hot, dry years really drive West Nile virus. And as a public health professional, that's really hard for me to continuously explain to people, because during those hot, dry years, normal mosquitoes that are biting us in our backyards when we're grilling out in the evening time kind of disappear. Those mosquitoes breed in floodwater, and so people don't really take precaution or think about mosquito bites during those droughts, because they're not getting bitten by those nuisance mosquitoes. However, West Nile virus always gets worse during those years. And the reason is because of that vector. This is a depiction of the life cycle of West Nile virus. And as you can see, the amplification cycle there in the middle between mosquitoes and birds during drought years, that can explode. And the reason is because of that mosquito. The mosquito that transmits West Nile virus here in Indiana and in the Midwest is a mosquito called Culex pipiens. And that mosquito loves to breed in containers. These are very common breeding areas in the urban environment, in our built environment, um, that they like to breed in. And these containers, it's during the drought years where they don't get flushed out, especially those catch basins under the street. During a normal summer, uh, a lot of those catch basins, as you can see in this picture, will hold water. Uh, and normally, when we get those big 1 inch rains, we can flush the organic matter and flush the mosquitoes' larvae out of it to kind of stop that breeding habitat. But it's during the droughts when that will just continuously break down organic matter, providing food for larval mosquitoes, and start churning tons of mosquitoes out. Because of containers having that surface area to volume ratio, it takes a big drought to dry those out, and quite frankly, never occurs. So things like tires can breed 500,000 mosquitoes a year. That picture on the top left, that's my son. And it's embarrassing as an entomologist crawling up on the in the gutters and seeing how many mosquitoes breed in clogged gutters every summer. But when we get those heavy rains, we flush those leaves out, clean those out so it doesn't breed. So West Nile virus here in the Midwest is definitely a drought disease, and that's depicted really well in this picture. I love this picture because, as you can see, there's all kinds of egg cases for mosquitoes in this jar, but the ground around it is cracked and dry. It obviously hasn't rained for a long time, but mosquitoes can breed in those containers uh, and really cause problems during those drought years. So, because of the complexity of several mosquito-borne diseases, one thing we do, and Dr. Faith Oy talked about this in her keynote address to this conference, is the need for surveillance. Surveillance is very important, and we'll get into several reasons why. But it's something we here in Indiana spend a ton of time, energy, and resources doing because it is very valuable information. Here in Indiana, we have around 60 species of mosquitoes. But honestly, I only care about a half a dozen or so of those because those are the only ones that can transmit disease. A lot of mosquitoes we have are just floodwater, just nuisance mosquitoes that can't transmit disease to people. So honestly, we don't study them that much. But we do have a handful of them that do transmit disease, and we focus on. Um, as you can see from this picture, we do utilize a ton of different traps in order to catch all those different mosquitoes. And there's a lot of benefit in that surveillance program. One of those benefits is just disease monitoring. So, one thing we do here in Indiana is we collect mosquitoes in all 92 counties, not only us at the State Department of Health, but several local health departments will send us mosquitoes, employ interns, and have a large mosquito surveillance program. And what that produces is this graph here in front of you. Uh, we can watch the infection rate of mosquitoes out in nature and predict human cases. If you want to talk about public health 101, one of the most beautiful things you can do is come up with a system where you don't have to react to outbreaks. You can actually predict them and have some lead time to stop those. And that's what this mosquito program does, is allow us 2 weeks in advance before we start seeing human cases to do some um, response. Not only can we put our messaging out, one thing I've learned through the years is people get tired of constant messaging. So if you can use data to help support your case, when we put out information to wear repellents. It's because there truly has been a documented increased risk, and it seems that people will listen better. But it also allows us in um, pest control to take public health measures by reducing mosquitoes outside. So if you can reduce the number of mosquitoes, you reduce the number of bites and therefore reduce the risk of vector-borne disease. And once we see an infection rate of about 4, we know we'll start to see human cases 2 weeks later. And that gives us 2 weeks to do all those things and to help prevent disease to the population. Another benefit of all our mosquito surveillance is, quite frankly, just knowing what mosquitoes are out there. The map on the left is where we have documented the presence of Aedes albopictus, which is an invasive mosquito that showed up in the United States in the 80s and here in Indiana in about 2001. This mosquito can transmit several different pathogens. Um, so just knowing where this mosquito is, we know where the potential for certain diseases are in the state and in the nation. On the right, you can see the CDC models of where they think these mosquitoes can be. And one of the great examples is Aedes aegypti up on the top part of the screen. Aedes aegypti is the mosquito that transmits things like dengue fever and chikungunya and several different tropical diseases. We've worked very hard in Indiana conducting surveillance for this, and quite frankly, we cannot find established populations. Therefore, we can establish risk of certain pathogens coming into the state. However, obviously, we have documented albopictus, so any disease it can transmit, we do have folks at risk here in Indiana, and therefore can plan for any disease that might pop up. That Aedes aegypti map got really important this year because of dengue. Dengue is a disease that's really getting a lot of popularity right now. Currently, we're recording this in mid-February. There is a large outbreak of dengue going on right now in Brazil. So far in 2024, even though we're only a month and a half in, Brazil has reported 500,000 dengue cases. And it's estimated that they can see as many as 5 million by the end of the year. So they're going through a current really bad outbreak. And because we're in a global economy, people can go to Brazil, become infected, and come here and can cause localized outbreaks when a mosquito bites them and becomes infected. And that's what occurred for the first time in California in 2023. California saw its first local dengue cases in 2023 down around Los Angeles. Dengue has also occurred in Arizona, Texas, and Florida. So knowing where that mosquito is in large populations will help us be able to respond to possible outbreaks. So it's not only just tropical diseases, but knowing where certain mosquitoes exist, help with all kinds of other diseases. This is a map of where Eastern equine encephalitis occurs in the United States. And as you can see, the northern tier of Indiana is involved in that. And even though this disease is extremely rare, usually we have around 7 cases of Eastern equine encephalitis in the whole United States. But because this mosquito involved in the enzootic cycle of this disease breeds in such a specific location, when you break those 7 cases down to just these few little areas, that increases its incidence quite a bit. That mosquito is Culiceta malinura, and it breeds in acidic water. So if we go back to the last slide, Those acidic environments only exist in a few locations. In the Northeast, that would be in the cedar swamps. In the South, that would be in the cypress swamps. And unfortunately, in the Midwest, that would also include sphagnum bogs in the Great Lakes area. That would include part of Indiana. So because of that, we only do eastern equine encephalitis surveillance in very specific habitats in those sphagnum bogs where we can find that mosquito. Um, as you can see in the right, it's all in that northern tier, and this is a really neat disease. How these bogs were formed was when the glaciers receded, chunks of them would fall off, um, and they would be covered in outwash. And as that ice would melt, it would create a kettle in the ground. Um, if that occurred in central Indiana, where our bedrock was limestone, that would turn into a lake. But unfortunately, in the Great Lakes region, uh, the bedrock is granite, and since that organic matter breaking down creates tons of free hydrogens, you end up with an acidic bog. So eventually, these will become peat bogs, but currently they're breeding nasty mosquitoes with a disease that the neuroinvasive form of that disease has around a 30% mortality rate. So we do a ton of surveillance for Eastern equine encephalitis to look for outbreaks on that. Another crazy thing that happened in 2023 was for the first time in 20 years, we had several locally acquired malaria cases. That occurred in Florida, Texas, Maryland, and Arkansas. And each one of those had outbreaks from an infected person coming back with malaria and then a mosquito biting them and then transmitting that to other folks. Um, and just knowing where those mosquitoes is knowing that potential. And unfortunately, the United States used to be a very malarious place. Basically, everywhere but the mountains used to have malaria. And because of several different factors, we had gotten rid of malaria in the 1940s, but we still have that potential with our global economy of little localized outbreaks occurring wherever we have Anopheles populations. And as you can tell from these maps, Anopheles, especially Anopheles quadrimaculatus and punctatus, can live about anywhere in the United States. So now we'll talk about tick-borne diseases. And tick-borne diseases are really interesting because it seems almost like the Wild West. The more we look at ticks and tick-borne diseases, the more we discover. There's all kinds of things out there, and this is a really exciting time. When I started this position 15, 18 years ago, this slide only had 3 tick species on it. Uh, at that point, we only had 3 ticks of medical importance that were prevalent in the state of Indiana. Just in my career, we've added 2 ticks, one of them this year. So tick-borne diseases are really exciting, and there's a lot of things we can do to not only control ticks, but to get awareness out there. So just as we talked at the very beginning, tick-borne diseases have really increased over the last 15 years for several reasons. But because of this, we have increased our funding in order to expand our tick surveillance to really see what was going on. We'll spend the rest of our time kind of talking about where we're at this point in that project. So we entered this project with really 4 goals. First, we wanted to see where Ixodes scapularis were. Ixodes scapularis are black-legged ticks, and they're the one that transmits Lyme disease. So we're going to start with the most prevalent disease, see where that is, see where those ticks are, and see how much disease is out there. Once we get that accomplished, let's see what other diseases are out there that tick transmits. And finally, we want to look at all the different tick species and see what's going out there. And this has been some really exciting work because we're finding all kinds of new things. So first, let's talk about some of the biological characteristics of this tick, and how that would affect not only our surveillance, but our risk as we're out there, both as pest control professionals doing our jobs and in our recreation. And the first part is, unlike mosquitoes who have several generations a year most of the time, ticks go through a very specific 2-year life cycle. And because of that, different tick life stages are going to be active during different times of the year. So, whether we're going to collect these ticks for surveillance reasons or we're outside working and need to avoid these ticks, it's certain times a year when they will be most active. Um, so, the larva, those eggs will hatch out in the late spring and early summer, and those larvae will be active in the summer months. Um, those larvae will feed on a small mammal or a ground dwelling bird. They will feed on that, drop off, and molt into a nymph, and that nymph will go dormant all through the fall and winter. And that nymph will not become active until the next late spring. It will then either feed on a small mammal or a large mammal, feed, drop off, molt into an adult, and that adult will be active usually when deer are active. So in the fall of the year and any time through the winter or spring when the weather's nice. So these ticks can actually be active year round, most active in the fall, and then again in the spring if they did not find a good blood meal. Oftentimes they'll get on that post, feed, mate, drop off. Females will then lay their eggs, and the males will then die. Um, so that 2-year life cycle uh, allows us to target ticks in their specific life stages during specific times of year. So unfortunately, in Indiana, those nymphs are most active usually around Memorial Day. And unfortunately, that's the busiest outdoor weekend of the year. So that's when nymphs are most active. And if we're going to do any messaging or control activities, that would be the best time to target those. Another characteristic of black-legged ticks is these ticks are really leaky. Um, the one characteristics that allow ticks to expand their geographic area is how well they can retain water. And black-legged ticks do a really bad job at that. They lose water very quickly. And because of that, they have to live in a very specific habitat. There's no trickery in this picture. Those are both my finger. And you can see how small black-legged ticks are. So if a tick that small will die if it loses 4% of its water, that's not a lot of water it needs to lose in order to die. So ticks have to live in a very specific habitat. In order to rehydrate, ticks actually can't drink. What they do, let's go to the next slide. Ticks have to go into a very high humidity environment in order to rehydrate. And the way they do that is get into an environment above 85%, spit a saline solution out on their mouth parts. That saline solution will absorb water vapor and then they'll suck it back up. So that's one place a tick has to have in order for it to survive is a spot with really high humidity. And their favorite spot would be under that leaf litter that shades the ground, keeps the ground moist, and gives them that environment to rehydrate. So if you're going to go look for black-legged ticks, you got to have leaf litter. Because they are so leaky, they also can't be in direct sunlight. So this is the habitat where you're going to find black-legged ticks. So not only are you going to have that leaf litter down on the bottom part of the ground, but you have to have a canopy above so they don't get hit by direct sunlight and dry out. With tick surveillance and tick awareness, mosquitoes come to us in our own backyards, but we have to go to the tick's habitat. So knowing where that is extremely important as far as public health goes. So, like I've mentioned before, black-legged ticks have really expanded. The map on the left, it is the known distribution of black-legged ticks in 1996. As you can see, the northeast part of the United States and the upper Midwest were the two hotspots for black-legged ticks. And over the next 30 years, those two populations seem to be converging right in Ohio. Uh, and they are really expanding into Indiana, as you can see from the map on the right. So this tick has expanded a lot in the last 30 years, hence why we're seeing so much more Lyme disease cases. The same is true right here in Indiana. This was our distribution map in 2001. And our distribution map in 2023 is completely darked out. We have found black-legged ticks in every single county in Indiana. So no matter where you live, the tick that can transmit Lyme disease is in your community. So everyone should take precautions. So the next step I talked about was looking to see what pathogens and at what rates are within these ticks that we collect. And so far we've done we're getting there, and we've tested a ton of ticks. So right now we're right around 8,000 ticks we've collected and tested. And some of these results are really shocking, and need to be shared with the public. So first is Borrelia burgdorferi. That's the bacteria that causes Lyme disease. We separate those ticks by life stage, adults and nymphs, and test them for that disease. And about 40% of the adult black-legged ticks we collect in Indiana are infected with Borrelia burgdorferi. So nearly half of the ticks out there are carrying that bacteria that causes Lyme disease. In the nymphs, it's about half of that, so around 20%, which is still really high. And nymphs are by far the life stage responsible for the most Lyme disease cases. And the reason for that, and all of this evidence shows it, is because these guys are extremely small. If you can see, that is just one nymphal black-legged tick on my knuckle. So one of the great things about black-legged ticks and Lyme disease is often they have to be attached to you for around 48 hours before they can start transmitting disease. Although these are small ticks relative to other ticks, adults, are often found when they're on our body. So as you can see from the disease cases by month versus when these ticks are active, it's the nymphs that are responsible for Lyme disease cases here in Indiana, even though they have half of the infectivity that adults have. But oftentimes when you shower, you're going to just notice a black-legged tick on you, an adult. Those nymphs are so small, oftentimes you're not going to discover them on your body until it's too late. So that's why in public health, not only do we really encourage repellents when we're out in those environments, but doing tick checks and showering when we get home is really important. If we wash those ticks off of us, check our bodies for them and get them off of us, the potential for disease to us drops dramatically. So not only do we test these ticks for Borrelia burgdorferi, the causative agent of Lyme disease, but we test them for several other diseases. One of those is anaplasmosis. Anaplasmosis is caused by another bacterium, Anaplasma phagocytophilum, and those nationwide have been about the same places where we see the most Lyme disease cases, the upper Midwest and the Northeast. In Indiana, we have only had 14 cases over the last 20 years. But one of the benefits of doing that surveillance and why Dr. Oy talked about how important it is awareness. And if we don't think a disease is here, we're probably not going to test for it. We are finding a ton of anaplasmosis in the ticks that we collect. Around 2% of them are infected with anaplasma. So getting that messaging out, if you do feel ill, we do have this disease out in nature. Um, Whereas you can see the tick map on the left versus the human map on the right, we have a lot of work to do with our messaging to inform folks what is out there and what we have the potential to get sick with. It gets even worse with some of the other pathogens we're detecting. This is the distribution map of Borrelia miyamotoi that we've discovered in ticks. This is a relatively new pathogen in the United States, and it causes hard tick relapsing fever. Um, as you can see, about the same infection rate we're finding in anaplasma in these ticks, but we have never had a human case reported in Indiana of this. So that is obviously somewhere where we need to do some work in educating the public, educating medical providers that this is out here in our ticks. The last one I'll talk about with black-legged ticks is babesiosis. Again, just like all the other diseases, and where we have our huge populations of black-legged ticks, babesiosis is thought to be in the northeast part of the United States and the upper Midwest. However, we are starting to find this in ticks. In certain locations, as many as 15% of the ticks we collect in specific spots have babesiosis. And this makes it a huge deal for providers because this isn't a bacterium. So far, all the diseases we've talked about that are tick-borne have all been bacteria. So whether they are different pathogens wasn't that important because they're all treated the same way with antibiotics. Babesiosis, however, it is a parasite. So it would be treated with anti-parasite drugs, like the same way you would treat malaria. So knowing that this disease is out there in nature is huge for providers because it would be a completely different medical intervention. That's the last one I'll talk about, but we're also finding a few viruses, which obviously antibiotics are not going to cure. So I cannot stress enough how important surveillance is and knowing what ticks and what pathogens are out there. So number 4 on our list of goals was to then expand to other ticks and other pathogens. The next most common tick in Indiana would be the Lone Star tick or Amblyomma maculatum. This tick is an interesting tick because this tick will actually come after you. Black-legged ticks, when they are questing for a blood meal, that is exactly what they do. They just quest. So black-legged ticks who do not have eyes, they're completely blind, will simply crawl up on tall grass and wave their arms in the air until a host walks by that they can feed on. They'll then grab hold of that host and then find a good spot to take a blood meal. Lone Star ticks, on the other hand, will hunt. So if you are a turkey hunter sitting in the woods in the springtime, those ticks will feel and will recognize that heat and carbon dioxide coming off of you and will actually crawl towards you and get on you to take a blood meal. Therefore, the tick burden, if you're sitting in the right spot in the woods in the springtime, can be huge. You can have tons of these ticks on you. And not only that, but they do transmit disease as well. So one of the things that they do transmit most prominently in Indiana is ehrlichiosis. Right now, we have 3 different species of ehrlichiosis. We have Ehrlichia chapiensis and Ehrlichia ewingii, which are transmitted by the Lone Star tick. But we also have found very small amounts of Ehrlichia murus occlurensis, which is transmitted by that black-legged tick. But over the years, Amblyomma americanum has been spreading, just like the black-legged tick has in Indiana, and nationwide, and it seems to be moving north. So we have large established populations in the southern third of the state, but we also have a pretty large population of this tick up in the Great Lakes area, and it transmits Ehrlichia everywhere it goes. Now, this tick is not nearly as leaky, so it can expand its environment farther than the black-legged tick can. When the black-legged tick, we find it nearly all the time in the woods. This tick likes to be kind of in that brushy area, kind of wood edges, because it can survive more in the sunshine. We start to find that kind of in the wood edges where animals will run in and out of woods and will encounter this tick. So it has a little bit different habitat. Um, and this is kind of some prime example of where we would find this tick. Lone Star ticks also have really complicated spit. All ticks do. Um, and one thing in Lone Star tick saliva is a sugar molecule that's called alpha gal. And unfortunately, this tick bite can also be associated with what's called alpha gal syndrome, which is an allergy to non mammalian red meat. So, this sugar molecule that's in that tick saliva is also in non mammalian meat. So, oftentimes, when people are getting bitten by ticks and their immune system responds, if it responds to that specific sugar molecule, the next time somebody eats, uh, non-mammalian meat, beef, pork, things like that, that contains that alpha gal sugar molecule, they could have an allergic reaction. And this is becoming very common in the United States. And this is something we are working on to study is how prominent this is. Because if you lay over the map of alpha gal syndrome cases and those with red meat allergies, that map fits really well with the distribution of Lone Star ticks. So not only can this tick transmit disease, but just its bite can cause all kinds of anguish for people and some allergic reactions and issues. Um, so if you're interested, look more into alpha gal syndrome. But it's a pretty serious issue, and we have several people here in Indiana who can no longer eat red meat or a lot of times those animal products such as milk. So it can be a big deal. So when we started these studies, I was convinced that we were going to find all kinds of new pathogens. But one thing that has really surprised me is the fact that we have actually found some new tick species here in Indiana as well. One example of that is Amblyomma maculatum, the Gulf Coast tick. As you can see from the map or guess from its name, this tick is a coastal tick. This is the CDC model where it could go as far north as Tennessee from the Gulf. But unfortunately, here in Indiana, we're finding it in pretty large populations as far north as Indianapolis, and even into Hamilton County. So not only do we have a new tick, but this tick is medically important because it transmits one of the spotted fever group rickettsias, Rickettsia parkeri. Um, so in the past few years, we have collected several of these and sent them to the CDC for testing. And around 20% of those are infected with parkeri. So not only do we have a new pathogen, but we have a new tick to transmit it. And it's not surprising that we're missing it because it looks really similar to American dog ticks. Those ticks we're all familiar with that people collect off their pets. The one big distinguishing characteristic between the two are their mouth parts. So down here at the bottom, this is Amblyomma maculatum. You can see it has a really long palps and mouth parts that would distinguish it from American dog tick. So if you happen to see one of these, you're more than welcome to send it to us because we are tracking the distribution of this tick. This tick is even less leaky than the other two. So it can live in just wide open grasslands where we would normally encounter just those dog ticks. They're very hardy ticks. They're very xerophilic, so they are resistant to desiccation. And this is the habitat we are finding in just large, wide open grasslands. Unfortunately, some of the dispersal characteristics of this tick is large. Often a tick will be able to travel on its host, and that would be how it would disperse. And this tick, as an immature stage, will feed on birds. Therefore, they're finding this tick occasionally as far north as Canada, because if it happens to feed on a bird, it can hitch a very long ride. And as adults, it likes to feed on large mammals, and especially deer that have a large range. So therefore, this tick can expand pretty rapidly. So we are watching for that to see where it does end up. Finally, one of the biggest news things here in Indiana, especially, is the introduction of Haemaphysalis longicornis, or the Asian longhorn tick. This is a brand new tick to the United States that was first officially discovered in 2017, but going back at other tick collections, was introduced probably around 3 times as early as 2010. But this is the first tick that has been introduced to the United States in nearly 80 years. Some of the characteristics of this tick is really scary. Asian longhorn tick populations here in the United States are parthenogenetic. Therefore, they do not need to mate in order to reproduce. This tick has finally done it. She does not need a man to reproduce. All she does is make copies of herself, and therefore populations can be explosive. If she's constantly making copies of herself, you can end up with a huge amount of ticks in a specific area, so large that in some pastures, these ticks can reach numbers where they can literally exsanguinate cattle. Just huge tick loads, and they have a very wide host range. The good news for us, they don't seem to have the taste for humans, but as far as pets, as far as livestock goes, this tick will feed on about anything. And unfortunately for our livestock industry, not only is this tick really aggressive and can exsanguinate animals, but it can also transmit animal diseases such as theileriosis that would cause anemia in cattle and die. So as of 2023, unfortunately, Indiana became the 19th state in the country to find this tick. We now have found it in 3 different counties, one of which is established. So this tick is not only of economic importance, but it's something that we will watch very strongly for the next few years to see how it expands, because obviously from its discovery in New Jersey in 2017, it's kind of exploded across the United States. We'll keep an eye out for that. Obviously, if you find a lot of ticks on you of different life stages, it could very well be this tick. Don't hesitate to reach out and let us know, because we are observing and documenting the presence of this tick. Other than that, with tick-borne diseases, I highly encourage people to wear repellents. Repellents truly work, folks. In the 10,000 ticks I've collected over the last 5-6 years, I've only had a handful of them attached to me. And really the main precaution is tick repellents and avoiding those prime tick habitats. There's a ton of different diseases out there, and it is up to us to protect ourselves and get those ticks off of us as soon as we can so they don't transmit disease to us. Other than that, there are all kinds of new control measures for ticks. So they can be controlled in backyards. And sometimes it's as easy as a lawnmower as a control tool. So if you have any questions, don't hesitate to reach out and have a great day.